Once again, we'll solve for R. So we get 1,000 R will be equal to, over, minus 900 plus 0.1175 watt. And finally, we get R is equal to 0.9 plus, with 3 zeros in front of that, 1175 watts. Where's the L on it?
Oh, can't see it in there.
This has got 3 zeros in front of it. How many does this have? 4. We should have 4 zeros.
In front of you. Yeah.
4 zeros.
4 zeros in front of 37?
37? Yeah.
So these are our two equations.
Just divide by 1. Negative.
Okay. What's the bottom one? I can't see.
That's 0.9 plus 0.000117.
It's 1,000 R.
Yeah, it's 1,000.
Now let's take a look at this. We'll start with this I this equation. We'll start with Y first. That will be equal to 0.336 minus 0.1234 37 times Y. We only have to go as far as this is possible.
Is that 4 zeros or 5?
Which one?
1 0 0
But,
What? Which one?
0.000037.
well, it looks like we got up to 10,000.
For iOS?
500.
0.336.
Equal 500. Now we'll put up the element. Now that's going to be equal to 0.9 plus, oh, that's the minus 0.9.
I don't know why.
I left the minus sign off over here. Minus 0.9.
Negative 0.9.
Go back here.
What did you leave the minus off of? The 900?
Yeah, 0.9 should be a minus 0.9. Plus
That's what the line curve?
0.30, 123,
This is by 500s now.
1175.
So to equals factor plus this.
So our-
to drag it down to 1.
So that's the L of the curve. Now, where the IS is equal to LN, right here, at 8,000. So let's see how that works.
Oh, you're on this side.
We can't see much here. We should open this up more. It's back.
That's pretty cool.
It is pretty
We
sweet.
can do that by, instead of going by 500, go by 200 first.
It's gonna be a huge graph.
What are you doing now?
It's changing to 200.
It's
so
gonna be
and
going on forever.
then drag that somewhere. Down to 200.
Yep.
So we keep going.
50.
Now we're at the party.
50 rows.
A little bit.
So you're going down at 10,000?
9,000.
9,000?
Yeah.
Oh, yeah, there you
But
go.
they're still equal over here, Nathan.
Yeah, change it a little bit. That's correct. It looks exactly the same.
It really does.
Yeah.
It looks exactly.
It's just different numbers.
All right, so let's move this.
Except it looks a little wobbly now.
I want to format this
Is
one
mine
first.
blue?
So I think
Yeah, yours does look good.
we'll have to add more. Instead of going by point two, I want to go by point. Oh, so can you see it?
What did you do to the left?
Let me go back.
Oh, you're fantastic.
Look at me.
They changed it to 0.04.
Yeah.
Now we- Good. And now we'll do the downward.
Yes.
What do you think?
Now we see both the IS and the LF equations. And what we see is that they cross right over here. When we go straight down, you go to 8,000. And when we come along here, they come to 0.04. All right? So what we're saying that in this situation, the economy would be stable, the GDP is 8,000, and the interest rate of 4%. Now,
Nice.
here's where the analytical part comes in. These are both straight lines. This portion up here is this 0.336 of the IS equation. Right? Now that 0.336 consists of this, the 3360 that we added up. Included in that stuff that we added up was this government. This was the government. So the government helps place this intersect point. Intercept point. That's the are intercepted, okay? Government spending fixed in there. We add that government up to these other two constants. This is the atomic consumption. And this is the the government is in here. So this 0.336 depends upon that government. Which means this point up here depends on government. Now, let me ask you now, what happens if government spending were to increase? What would happen to this point over here? If the government increases government spending?
You go down.
It'd go up, right? That point would move up because it's a positive point.
Yeah.
If government increases, this would move up. Now, if that moves up, and let me move it up, just to give you an idea what happens. I'm going to change that. I'm going to increase government. I'm going to move that up to, say, 0.4.
So the highest.
But you can see what happens if it doesn't move up. Let's say it moves up. Let me go back to here.
Wait, the IS card is just right.
If that point moves up and we don't change the slope of this line,
But the LM is money supply.
if we increase government, that point goes up, and we don't change the slope of this line. The new IS equation will be parallel to this, like this.
To the D, right?
Everybody follow that?
Wait. Yeah.
So it shifts it up, the whole
Yeah,
thing.
the whole
Yeah,
thing shifts
shift
up.
the whole government, the whole IS curve on, government increases.
Okay.
What happens? We now cross over here instead of over here. So GDP goes up this way, but the interest rate goes up. The interest rate will go up from here up to here. See that?
Yeah, I see, actually, yeah, I see that.
So what government spending causes in the short run is an increase in GDP and a little inflation, both of which we need right now. Both of which we need. We need a little inflation. We need a little increase in GDP. If we cut government spending like the Republicans want to do, we'll go the opposite way. If in the negotiations they cut government spending, instead of that line going above, this point will come down, and will come down here, like that. So if GDP is here, GDP is going to go down that way. It's going to aggravate our unemployment problems. It'll bring our interest rates down. But our interest rates are already too far down.
What would happen to the LM curve?
We just haven't gotten there yet.
Ah, let's get there.
Well, look at it. LM curve right now hasn't moved.
Can you show that Word document one more time? If you don't mind?
But try to follow this logic. You can see what government spending does. It shifts the IS curve up and down. And it'll cross the LM curve in different places. Now, before I show you that document, I want you to look at one other. The taxes were incorporated over here. It was 0.1 minus 0.3. The tax equation is 1 minus 0.2, right?
Yeah.
If you increase taxes, all right, then this 0.7 would go down. 0.9 times 0.7, that would go down. That would go down to a lower number.
Yeah.
All right?
It's straight from the one.
Follow that?
Yeah, I got you.
But it's on a negative. So we get a lower negative. What the changes in taxes does, it changes the slope. If taxes go up, it changes the slope. So the slope of the curve goes this way. In other words, this goes like this when taxes go up. This is why the Congressional Budget Laws pointed this out, because this is bad. If you do either one of these two things, either lower government spending or raise taxes, you're going to play havoc with this LM curve, an IS curve. Right? And it's going to lower the GDP. Now, so we can see what we're dealing with. We're dealing with a situation where they want to do something, but anything they do will be bad for the economy. Better they don't do anything. Let the economy take off. It's moving along nicely.
That's good.
Now let's take a look at the LM curve. Here's the LM curve. It's 0.9 times this. Minus 0.9. Remember I pointed out I made a mistake, but that's just minus 1. And it hooks in over here. Now, the 0.9 comes from here. This is the money supply. The money supply. We get that money supply through the Federal Reserve. The Federal Reserve sets the money supply. They do it by manipulation. They set that money supply. Did you wake that guy up? Oh. Wake up.
I'm scared. I'm scared.
Now, let's suppose you increase money supply. It's negative, right? What happens when you increase the negative? Where will this point go?
Down.
It'll go down. If you increase the money supply, that point will go down. And if it goes down, and you don't change the slope, this line will go like this. Spread it out.
Yeah, we'll have something.
Curve out.
I'll just pretend that way. It's fine.
Like that. Right. But if we were intersecting here at 8,000, now we'll intersect out here beyond 8,000. By increasing the money supply, you increase GDP, you decrease unemployment. Right? And if you decrease unemployment, at the same time, look what happens to your interest rate. Your interest rate is now falling. You're lowering your interest rate. Whenever you increase the money supply, you lower the interest rate, and you increase the GDP.
When you say money supply, are you talking about M2 specifically?
M2.
Okay.
But you're talking about without any movement in the IS curve, right?
Right. Now, if you do both, you got to watch how both curves react.
But won't they both interact with each other that way anyway?
No. they're
Like
independent.
if you decrease government spending, then the money supply will shrink, right? And then,
No,
so
no.
the LM and the IS curve will move at the same time.
If you decrease government spending, then you'll bring this down. And that shifts it back to the other way. All right?
So if you decrease your government spending, the reduction in the money supply won't happen and the LM curve won't shift left, or shift left, up?
If you decrease government spending, it won't have anything to do with the LM curve. The LM curve is only controlled by the money supply.
Yeah, but wouldn't that make sense, though, if the government wasn't spending as much, the Fed wouldn't have to print so much to keep up with the spending?
No, no. That Fed doesn't work that way. It doesn't, the Fed does not print money. What it does, it auctions off bonds to change the interest rates.
Okay.
It doesn't print money. The Nazis did that World War II. Our Fed doesn't do that. All right. These two curves move independent. They have independent ways of going back and forth. And this got shown. Likewise, if you decrease the money supply, this curve goes up, and you'll get less GDP. So if you decrease the money supply, you get less GDP. If you increase the money supply, you get more. Remember, these two curves are independently controlled. That's why we have an independent central bank. That's the whole reason for the independent central bank. Keep that LM curve independent of the fiscal policy. The IS curve responds to fiscal policy, the LM curve responds to monetary policy. And they have different effects. Now, they can help each other. I mean, when the Fed looks at the two curves, they decide which way they want to move. They try to complement what's happening in fiscal policy. But that's the way you have to think about what happens when they increase government spending, decrease government spending, increase taxes, decrease taxes. Think about these IS and LM curves shifting.
that?
Now, I just want to show you, that's part of this. Let me see.
Pretty awesome.
I just shared my documents with you. Just in case you want to. I just sent you a
We can algebraically see what happens when we put these together. Remember the LM curve started like this. With 900. And we had this, we had a P, but we said P was equal to 1, so we can just take it out.
Yeah.
But suppose we don't take P out. We leave P as a variable, right? Then the LM curve will change like this. Now this is the nominal money supply. In other words, that's the money supply in current values, current dollars. When you divide by P, what does it become? Real. This is the real money supply, right? And that'll be equal to now, let us solve this for R. Like we do over here. Now, I'm going to interchange these two. Oh, we'll leave it. Now we'll divide by R. We'll go down. P. Now this becomes what became before. This is 0.0001175y minus 0.9 times P. Right, P is the denominator. Okay. Now, when the LM, when the IS curve equal the LM curve, then we'll have, this is our IS curve here. Speak. Now, if we bring the two y's together and make over on this side and these two on the other side, so we'll have 0.000037y plus 0.000175y. That'll equal 0.336 plus 0.9 p. And now we can factor out the y's out of this. have to add these two. So we have so this becomes 0.0001 545y is equal to 0.336 plus 0.9p. And now we'll divide both sides by that and get y. This is called the aggregate demand curve. Y will be equal to 0.336 divided by 0.000155 plus 0.9 over 0.000155 p. Who's got a calculator? Okay. Let's get this term first.
The first is 2170.
What?
It's 2174.75.
76.
21,
74.76.
73. Is that what you got?
Yes.
Okay, now, what happens when we take 0.9 divided by it? It's gotta be about 5 something.
5825.24.
5, 8, correct?
25.24.
25.24 over p. Now let's see if that's correct. We put p equal to 1, they have to add up to 8,000. If we know what happens when p equals 1, we get 8,000. We get 2134.
It just means
Plus
plus.
73 plus
It can at 24.73. At the end, it's not going to add up exactly. Some of those numbers will be out.
It's gonna be rounded up. It's gonna be 0.99.
So
I don't believe
That's
in rounding.
74 or 24?
Give me exact numbers.
there's 2 4.
Oh, right. Oh, wow, it's off. 0.97.
3 and 4 is 7. This is 9.
Yeah, just not.
This is 9. 3 and 2 is 5. 8 and 1 is
2959.97.
9. What is it, 79?
Yes.
59? It's not, you guys didn't give me good numbers.
Yep.
Can't be. They don't add up right.
So you gave us y at some point already?
I gave you this.
Let's round it to 8,000.
0.336 over that, 0.9 over that. 0.33. So I'll have to go on Excel.
Then I think that's 2175.
This is 21.
It's 2174.70.
That's what I said, but
75. 2174.
2175.73.
It's actually
2174.75.
75.
74.75.
74.
And then change the 3 to a 5.
That's better. All right. So now this becomes 74.
yeah,
And this is a 5. Let's see how this goes.
So 58, 25, 24.
9.
Yeah, now.
Nine.
9,
9.
7.
7.
7, yeah.
Close enough.
Yeah.
Another penny would be 8,000.
He's rounding. Good enough for rounding.
Right? So that's a very good. Now we got it, right?